Can we code a mini version of MS Paint in pure JavaScript, including that glorious Windows 95 spray can tool? Let's find out. Today we're using the free online editor at editor.p5js.org. Let's start by getting all nostalgic and set the background to that calming teal color from Windows 95. Let's define some global variables representing the main paint window, the tool we're currently painting with, the color we're painting with, an icon for our app, and menu bar icons for each of the painting tools. Let's define what painting tools we'll implement in our app. Let's also quickly write out all the colors in our paint palette in the order we want them to appear. Next, we need to load the image icons we plan to use. I've created a directory called Images and uploaded all of the icons there. We'll load the icon for the main window and store it in the global icon variable we defined before. Next, I'll loop through the available tools we defined above and load 2 icons for each, a default icon as well as an on icon. The on icon is just the same icon but with a lighter background. This makes it more obvious which tool is currently selected. Before we can start drawing the user interface, we need to define some pixel measurements for our layout. We'll come back to these in a minute. Let's make a start now defining our main paint window class. The constructor will take the top left X and Y position, as well as the window's width, height, and title. We'll also keep track of whether the window is visible or not. We'll create a basic draw method for now. If the window is not visible, we'll simply return, which means nothing will be drawn. Otherwise, let's just draw the basic gray shape of the window. While I'm here, I'm going to add some empty mouse-related methods too. Let's create our paint window object by calling its constructor in the setup function. We'll provide its X and Y position, size, and title. Then we'll call the paint window's draw method. Finally, we can see it drawn to the screen. Next, we'll create a new method to draw the title bar of our window. Let's draw the title bar as a rectangle with that classic Windows dark blue. Next, we'll draw our fake paint icon to make the title bar look authentic. This was the global icon image we loaded previously. Then let's draw the title of our window. We'll set the font color to white and 12 points high. We'll use Courier New as the font and set its weight to bold. Nice. Back in the draw method, let's also add a new dim gray background behind where our canvas will eventually go. This will give us the basic bones of our window layout. You'll notice I'm using a lot of the constant pixel values we defined earlier, such as padding and title bar height. These values are often called magic numbers, and you work them out either by manually measuring the number of pixels or just guessing and seeing what looks good. I did a little of both in this case. Before we create the rest of our user interface, we need to be able to create buttons for our users to click on. Let's define a general button class now. Our button class constructor will accept a X and Y position, a width and height, a text label, and also an action function to execute when the button is clicked. We can also optionally specify a fill color for the button or an image to make the button look pretty. Next, we'll implement a draw method. If the button has an image, we'll prioritize drawing that. We'll calculate the image's X and Y coordinate to be centered within our button. If the button doesn't have an image, we'll color it with its fill color, or a light gray if it doesn't have a fill color. We'll then draw a black outline around our button. If a button is transparent, I'm going to render its label centered inside the button. I'm only going to really use this feature to display the little X inside the Windows Close button. Finally, let's implement our button's mouse pressed function. When the user clicks anywhere on the screen, the click's X and Y coordinates will be fed to each button's mouse pressed function as MX and MY, or mouse X and mouse Y. We'll then check to see if the click occurred within the bounds of this particular button. If so, we'll call the button's action function. Otherwise, we just ignore the click. Okay, let's now use our freshly defined button class to implement the Windows Close button. We'll define the close button inside the Paint Windows constructor with an appropriate X and Y coordinate and a width and height equal to the icon size constant, which is set to 16 pixels. The label will set to just a lowercase x. We also need to pass an action function. We'll create an inline anonymous function, which will simply set the Paint Windows this.visible variable to false. You'll remember from the draw function below, if this.visible is set to false, Then the draw function will return early, meaning our window won't get drawn. We can now draw the button by calling the button's draw method while we're drawing the main paint window. We also need to patch through any mouse clicks to the button's mouse pressed method. That way the button will get notified of any clicks as they bubble up through the paint window. Speaking of bubbling up, the final thing we need to do is actually send the global mouse events to our paint window class. We'll do this by implementing 3 high-level P5JS functions: mouse pressed, mouse dragged, and mouse released. In these functions, we send the data up to our paint window. That way it can manage things from there. Let's now test out our new button. Nice! We can now close our window. To reopen it, we just run our project again. Let's start laying out our palette now with all those glorious Windows 95 colors. I'm creating a new class to represent our palette. It will accept an X and Y position, as well as a width and height. We'll also define a class variable called color buttons to hold all the buttons a user can click on to select a color. We'll loop through all of the web colors we defined at the top of our file and create a new button for each one. Next, I need to calculate the position of each button. Our palette will be split across 2 rows, each containing 14 colors. I'll create a convenience variable to keep track of the index of the last item at the end of the first row. This just makes the code cleaner. I'll then calculate the row index for this color, either 0 or 1, and its column. This is based on the variable I, which is the color's index inside the web colors array. The column index will be a number between 0 and 13, since indexes in JavaScript start at 0, and we have 14 colors per row. I can then calculate the button's X and Y position based on its column and row. I'm also going to leave a gap on the left side of the palette so we can render the currently selected color. I've done this by adding the height of the palette to the X coordinate. This is somewhat arbitrary, but I think it will look good. Now we can push a new button instance for this color onto our color buttons array, setting its position and size. We'll set the label to be the name of the color, and inside the button's action method, we'll update the global variable current color with the name of the color. We'll then set the button's color to be, the same color, of course. Since we did all the hard work when we defined the button class, we'll only need to call the draw method for each button. If we now go back to our paint window class, we can create a shiny new instance of our palette and call its draw method. The palette should now appear. Hooray, that looks amazing. Let's add a darker background now behind our palette area to make it more authentic. Let's also add a box to display which color the user currently has selected. We'll start by just drawing a light gray rectangle as a background. Before we draw the selected color, I want to first draw a little black drop shadow that will sit slightly offset from the selected color. Now we can go ahead and draw the currently selected color in the center of the rectangle. Before we can see the selected color change, we need to implement a mouse-pressed method for our newly created palette. In this method, we'll simply pass the global mouse click data down to each color button. That way the button can determine if it has been clicked on and set the global current color variable. Let's add that mouse-pressed method to our palette now. And then finally, back up in our paint window, we just need to send the click data to our palette's mouse-pressed method. We should now be able to change the selected color using our palette. Cool, now we're cooking with gas. Let's now start work on the left-hand toolbar so users can select a painting tool. We haven't created the toolbar class yet, but let's just quickly write all the boring initialization code because it's exactly the same. I need to create an instance of the toolbar class, providing it with an X and Y position, as well as a width and height. I also need to call the toolbar's draw method and pass any click data to its mouse-pressed method. You've seen me do this before. Now, I'll create a skeleton toolbar class with a constructor, a draw method, and a mouse-pressed method. Like we did with our palette class, let's draw a slightly darker rectangle under the toolbar. And, while I'm here, I'll go ahead and call the draw method on all the toolbar buttons. However, at this point, we haven't created any buttons yet. I'll also patch the mouse click data through to each of the toolbar buttons. That way, as soon as we've created our buttons, they'll start working. Okay, time to create the toolbar buttons. Remember when I loaded two kinds of toolbar icons, an default icon and an on icon? Well, I'll need to create a new class that will know how to handle the toolbar button's on state. I'm creating a new class called toolbar button that extends our existing button class. It has the same arguments as a button, plus a new one called onImage. Inside the constructor, I'll call the parent constructor, in other words, the button class, by using the super method and passing it all the arguments for a button. Then, I'll store a copy of the onImage in its own class variable. Now we can write a new specialized draw method. If the global current tool variable is the same as the label of this button, and the onImage is not null, in other words, it exists, we want to draw the onImage. Otherwise, we just want to call the original draw method of the button class. We can do this by again using super. Okay, all we need to do now is to loop through all of the available tools that we defined at the top of our file, calculate their row and column index, and then push a new instance of toolbar button onto our toolbar buttons array. We'll need to specify its X and Y position, which will be based on its row and column, give it a size and a label. We also need to specify the action function, which, in this case, will simply set the current tool variable to the name of the tool. Finally, we need to provide both a default icon and an on icon. If we run our code now, we should see our toolbar appear. Great! That's looking very authentic. When I choose a new tool from the toolbar menu, its on icon toggles correctly. We're now getting to the really fun part, implementing our canvas class and all of the fun painting tools. Again, I'll speed through the initialization code since you've seen me do this twice already. I'll initialize a new canvas class instance, which will store our painting. Like always, it needs an X and Y and a width and height. Then, inside the paint window's draw method, we'll call the draw method of the soon-to-be implemented canvas class. And finally, we need to wire the mouse pressed, mouse dragged, and mouse released events through to the canvas so we know what the user is trying to paint. Let's now create our basic canvas class. We need a constructor with arguments for the X and Y position, as well as its width and height. We also need a draw method. For now, we'll simply draw a plain white rectangle. And finally, we need those three mouse event methods. The first thing I want to do is create a P5 graphics object. We'll call it a buffer to store the user's painting. I'll set the buffer's background color to white. Then, inside the canvas draw method, we will draw the buffer as an image at the canvas's X and Y position. In the future, when data is written to the buffer, it will be displayed correctly. Okay, let's start work on arguably the best painting tool of them all, the spray paint tool. To get started, we need to do something when the user presses their mouse button on the paint area with the spray can selected. The mouse pressed method inside our canvas class will get called with an MX and MY coordinate. However, this coordinate will be relative to the entire P5 drawing area, not the user painting area. Therefore, we need to translate the click coordinates so they are relative to the top left of our user painting area, starting at 0, 0. I'll do this by creating some new variables, adjusted X and adjusted Y, where I'll simply subtract the X and Y coordinates of the canvas class. Next, I'll use a switch statement to see which painting tool we have currently selected, and if it's the spray can, we'll call the spray paint method with our adjusted X and Y values. Let's now write this method. I'm going to define a density variable which will hold the number of dots we'll spray per frame, and a radius for our paint can nozzle. I'll also go ahead and set the stroke color to the currently selected color, and set the stroke weight to 1. Let's make our spray paint tool work by adding a loop that sprays dots around the mouse position, using random angles and distances, within a set radius to mimic spray paint. Then we need to dust off our high school trigonometry to work out their exact X and Y coordinates, and paint those as a point to our buffer. Believe it or not, we've just coded a basic spray paint tool. Cool, it works, but one problem is I can't hold my mouse down and spray paint continuously. Let's fix that. Inside the mouse dragged method, I'll basically copy what we did in mouse pressed. Amazing. That's working perfectly. Let's move on to the eraser tool now. I'll start by calling the eraser method inside mouse dragged, if the user has the eraser selected. I'm also going to pass an adjusted previous mouse, or P-mouse, X and Y position from the prior frame. This variable is automatically set by P5. We can now write the eraser method. To simplify things, I'm going to assume that our canvas is always white, and I'll set the stroke to white with a stroke weight of 10. Then it's simply a matter of drawing a line from the previous mouse position to the current position. Done. Next, let's start working on the pencil and brush tools. The first thing I want to do is keep track of our adjusted X and Y values from frame to frame. I'll create some variables in our constructor to do this. I also want to write a little helper method called mouse inside canvas, so I know if the mouse cursor is currently inside the user painting area. I'll test to see if the user is inside the canvas on every mouse event. If not, I can simply return early. Let's also define another little helper method called stroke weight that will simply return the correct weight based on the tool we have selected. For the brush tool, we'll return 5, otherwise we'll return 1. When the user clicks the mouse once with either the pencil or brush tool, we want to paint a simple dot or point. However, like the spray paint tool, this isn't a great experience since it takes a long time to paint something one dot at a time. Therefore, we'll need to implement the mouse dragged method. Before we can do that, I need to set a fresh copy of the last adjusted X and Y coordinates immediately after the click. Now, inside of mouse dragged, if the last adjusted values aren't null, we can draw a line from the last position to the mouse's current position. We then need to update the last adjusted values, ready for the next mouse move. The final thing we need to do is set last adjusted to null when the user releases the mouse. Otherwise, our drawing will never end. Nice! We just implemented 2 more painting tools. Let's move on to implementing drawing shapes, i.e., lines, rectangles, and circles. I'm going to start by defining a shape anchor X and Y coordinate. This will be the point where the user clicks to start drawing the shape. These will be set to null if the user isn't drawing a shape. I'll create a helper function called isDrawingShape that will return true if the X shape anchor isn't null. This will just make our code a little easier to read. I'll create a method called beginShape that will simply set the shape anchor X and Y values. I'll also create an endShape method that we'll call a drawShape method if we're currently drawing a shape. It will also set the shape anchor to null since we're finished drawing. We can now call beginShape inside the mousePressed method and endShape inside the mouseReleased method. Let's now write the drawShape method. In addition to the type of shape and the bounding box X and Y coordinates, I'm also going to pass a persist parameter. This determines whether to just draw a temporary preview of the shape to the screen or whether I should permanently write the shape to our buffer. The rest of the code in this method is fairly self-explanatory. If we're drawing a line, we draw a line. If we're drawing a rectangle, we draw a rectangle. You get the idea. Let's try these tools out now. Okay, they work, but we can't actually see what we're drawing because we haven't implemented the preview yet. Let's go back to the canvas draw method and add a live preview. If we're drawing a shape and the mouse isn't outside of the canvas, then we'll draw the shape relative to the entire application window, not the buffer, and we'll set persist to false. This means the preview will be redrawn every frame, making it interactive. Let's take a look. Great! That's 3 more painting tools finished. The only thing remaining is to implement the boss mode painting tool. Flood fill. Flood fill is quite tricky, and I'm going to gloss over some details, as I could probably do an entire video just on flood fill. Let's define our flood fill method. We'll define new color to store the currently selected color as a color variable. I'm going to refresh the pixel data in the buffer to make sure everything is up to date. We'll create another variable called target color, which will be equal to the color of the pixel where the user clicked. If the color where the user clicked is the same as the current color, we just want to return, because the area has already been painted. To check if the colors are equal, we'll need to create the this.colorSequal method, which doesn't exist yet. To check if 2 colors are equal, I first need to normalize them to be in the same format, because colors can be represented in different ways in P5. Then I simply check if the red, blue, green, and alpha values are within a certain amount, or a tolerance, of each other. If they are, we'll say the colors are equal. Therefore, if we have a red color and another red color, but it's just ever so slightly a more yellow red, then we'll say they're the same color. To normalize a color, if a color is an instance of a P5 color object, we'll return the RGB values, plus the alpha channel as an array. Otherwise, the color is already an array. We'll just make sure it has 4 elements. Let's go back up to the flood fill method and continue writing the logic. I'm going to keep track of all the pixels I've visited as I'm scanning our painting area. This is so we don't keep checking the same pixels over and over again, thousands or millions of times, which might crash our browser. I'm also going to create a queue of pixels to inspect, starting with the X and Y coordinate of the click. Then we'll keep looping through our queue while there are items. At this point, there's just one item, the point where the user clicked. Inside the loop, I'll grab the first item from our queue and calculate a unique ID for this pixel. The ID is just the pixels index inside the buffer's one-dimensional pixel array. This is more efficient than using X and Y coordinates when storing pixels. If we haven't visited this pixel before, we'll change its color to the new fill color and add it to the pixels visited set. Then we'll define the 4 cardinal directions, north, east, south, and west, so we can check the pixel's neighbors. We'll then loop through those directions and call a new inline function shouldColorPixel, which will return true if we haven't visited this pixel before, and the pixel's color doesn't match the target color. If so, we'll add it to our queue so that we can color in that pixel and also inspect its neighbors, and so on. I'll quickly write the shouldColorPixel method as I've just described it. At the top of the function, I want to also check if the pixel is not off the edge of the canvas, so we know when to finish our flood fill. Almost done. The final thing we need to do is update the pixel data at the end of our flood fill method. Otherwise, we won't immediately see our changes. I also want to write a little function that basically copies our buffer again into a fresh new clean buffer. I found that if I don't do this, sometimes the flood fill doesn't stick. That's it. We've implemented a basic flood fill. Let's see if it works. It works. It's a little janky around the edges, but not too bad for a first attempt. Our project is now finished. If you want to learn to code in bite-sized steps, like this video and subscribe. Until next time, happy coding.